Hello. Oh, you're here. Yeah, welcome to the future of technology. This is definitely not a hastily assembled panel that we did at last minute because we couldn't find one of the speakers ended up pulling out, unfortunately.
No, that was me.
Oh, hey, oh, you're here.
But you're fine then.
Oh, yes, I think. Oh, right, okay. I think we're. Yeah. I think we're in the right place.
Maybe we should have a brief intermission while we find out.
Yeah, 2 seconds. Do you want to go and figure it out? I guess we carry on chatting anyway, and we may just stop and switch to something else. Unless you want to listen to some more music. Nah, we'll get on with it. Right, I'll need you all to tweet me questions. I can pick them up on here. We've got plenty of stuff to talk about for the next 5 hours. I think it's not going to take that long. But if you have anything in particular that you want us to digress into, if you've got any questions that around the topics we're discussing, as you get them out.
So I've kicked her out, right?
Yep.
No, I was asked
Okay.
to come on the panel and.
Oh, okay. Okay. You can decide on
on
this.
the panel.
This is so. Hey, welcome to the panel. Hi. So let's start off with who we are. But if you've got any questions as we roam through the obviously really narrowly scoped concept of what the future is, feel free to please send them over on Twitter. This is not Katherine Beaumont. I'll start with you. This is Paul Jenkins.
Yeah.
What your Oracle, right?
Yes.
Test. Yep. There we go. What do you do at Oracle?
I work down the road in Oracle in the cloud development team, working as product manager for infrastructure as a service offerings.
Okay. This is Ben Gaster.
Hi, I'm a lecturer at the University of West of England, where I teach computer science and other fun subjects. And my research interests are kind of into radio networks and also programming language design.
Kate Stanley.
Hello. So I'm an IBM developer. I have been working on WebSphere Liberty and then more recently on microservices and also in the cloud developer services in IBM. So looking at how we can improve Java development on our cloud platform. And I did a talk today about Game On and microservice security.
And Simon Ritter.
Yes, who hopefully most of you saw me this morning doing the keynote. So
I just want to point out one thing. I seem to be surrounded by Java people. I hate Java.
Oh, good start. Good start.
Oh, but a good point. I'm not Java.
okay, that's a good question then. So why do you hate Java?
Well, partly because it's. I don't think an object-all approach is very good, and I don't think you can argue lambdas has really solved that. And it's quite a clunky language to use. And I understand why it's trailed behind C#, until recently at least. But it's incredible that it still hasn't got async, for example. And
JDK 9.
And streams are okay. I quite like the streams and the declarative stuff. Definitely, that's a good. I think Java 8 and Java 9, to be fair, are much better. Unfortunately, I have to teach pre-Java 8, and so that's frustrating. And I think, no, so it has its place, absolutely. I think it's really good, and it's very good. I think it has been used in the wrong places at times. And I certainly feel from most of my work in industry has been at C++ level, so I have a bias from that. However, I completely accept that C++ shouldn't be used everywhere. The other problem I have, which from a personal perspective, is that because it hides the machine so much, when we teach it as a first language, I end up with second-year students who are basically morons because they don't know what a cache is, and they don't know that they can't even really describe what a virtual machine is, let alone how it would be compiled. So it's personal problems rather than Java has been a huge success, and I suspect it continue to be, and it's the right thing for right thing. It's the right language for some things, not for everything.
So where would you say it's been inappropriately used in the past, or even currently?
The cloud, the back end, service. So I'm much more of a node person. I think it scales much better and that. But the base where it was misused was applets, right? I know that's not getting so much now, but that was a terrible mistake, right? Yeah. And
You'd struggle to find an applet champion.
Yeah.
Any applet champions in the audience?
Okay. Anybody still using applets? No. Well, there you
The
go.
other thing, I mean, FX, of course, is now improving that a lot, but Swing, yeah, has had a lot of issues, right? Let's say.
Yes,
Yeah,
and it's kind of like
I
20
think-
years old. So
Yeah, so and I think that's drawn back a bit. So, you know, I think it has its place. It's been hugely successful in the back end and in servers, and I think Oracle, of course, uses it extensively in other places. So I think that's great.
Do you think Java's it? Is obviously the conversation comes around every 2 minutes of is Java dead? And looking forward, is Java a language that's going to be continued with? Is even the JVM something that is going to be something that our grandkids might be developing with, given that that my parents would have been working with Java?
Well, I'm not sure about your grandkids, but certainly for the foreseeable future, as in, I mean, when I say foreseeable future, 5 years, I think, yes, Java will continue to be very, very popular, and the VM will be continue to be very popular. And the reason for that really is because it does abstract away a lot of the problems that developers have. And I know, you know, from a teaching perspective, that's not great, but from a developer's perspective, you know, you don't have to worry about memory management. You don't have to worry about thread management in the sense of, you know, interacting with the operating system. And it does isolate you from those things. So that's very, very helpful from a developer perspective. So I think that will continue to be used. And the fact that, you know, performance of it has really kind of grown over time. So it's a nice entrenched, embedded sort of thing that, well, not embedded as, you know, but it's very ubiquitous, shall we say.
So the challenge I have with that is you could say exactly the same things about PHP. It has a VM, it's got no memory management, it deals with threads, it has grown in performance over the years. In fact, it makes this nice abstraction and there's a ton of libraries with it. Why are we still so pinned to Java or even to C# when it comes to architecting and structuring large applications?
But are we? I mean, who uses PHP here? Okay, well, maybe the wrong audience to ask, but I see a lot of people using PHP. Yeah, Java's more popular, but PHP is still very popular. And it does get used for back-end applications. I see a fair amount of use of PHP in back-end applications. So I think it's fair to say that, you know, that's an alternative. And there are other alternatives in terms of languages and things that people can use. So, I mean, like you're talking about Node as an alternative. Lots of people do use alternatives, but Java does tend to maintain its level of popularity.
I think in some ways, with a lot of languages, there's always the good points and the bad points. And I think actually one of the interesting kind of things around microservices is that now people are kind of really considering doing polyglot applications that actually we can really maybe not put in every language under the sun in one application, but we can kind of pick and choose, like if we're doing some piece of functionality that is really suited to Node or a different piece is really suited to Java, we can really pick and choose and kind of build up expertise in two areas. I was just curious to know if someone came to you and said, like, what language should I learn first, or like, what's your favourite language? What would it be? C# then, or what would it be?
Me, asking me
Yeah.
that question. I don't know. C. No.
Algo.
No. I honestly, I don't know. Actually, it's very difficult. I mean, I taught for a long time when I lived in the US. I taught at Stanford, and my proposed language there would be very different to the language I get for university with students. You know, and because at Stanford, I would actually C wouldn't actually be a bad choice, right? Because we teach architecture in the first year aggressively. You know, Patterson and people are there. Whereas we touch on architecture in the third year, of course, you know, and so I think Java is not necessarily a bad language. I think no, actually in Java 8, probably with its nice new loops and all that sort of stuff, I think it's actually not an unreasonable thing to do. Anything, I would definitely say language has got lambdas. I think that's really important in the modern day, and you know, it's a way of thinking. And that is my frustration with Java, is not the lambdas, because actually I quite like them in Java, but is the fact that everything's been a class, and it is a bit clunky when you're teaching in that. You know, you always have to introduce classes straight away, which is problematic, I find. And also, it's not a good abstraction for everything, and so it's frustrating. Most other modern object-oriented languages, if you want to call them that, don't just require only classes. You know, C++, JavaScript, Python, they don't, you know, you can do other, and I think that is a drawback. And that is something that would probably stop me from teaching it as a first language. But that's the only reason.
So is the power of the really then the JVM? I mean, there are plenty of languages that run on top of the JVM.
Teach Clojure.
Not all. In fact, most of them are functional and don't require you to have an object-orientated structure to begin with. I mean, pick up Groovy, and it's you can build functions quite quickly out of it. Is it really the value then in the JVM, or are we clinging on to something because we're just so familiar with it?
I personally think the JVM is great, actually, and I think that's been a success, right? That's why it's been successful. I mean, I think you can't argue that the language is necessarily great, personally. But then sort of language like Scala, which I quite like and I'd be quite good at, is really complicated to teach a first-year student. You know, when you start talking about bounded polymorphism and things like that, they'll be like, you know, they can't even get the idea of a generic, and generics are pretty basic in Java. And so I think that's the difficulty. And Clojure, then you don't have types, and I would never teach a language that doesn't have types except for C. But, you know.
So we've talked about various different languages. However, as you pointed out, having many different languages means that you can often end up with needing polyglot programmers. And if you've got 10 microservices and 10 developers with 10 different languages, how does that scale inside of an organization? Doesn't it just pin responsibility onto people?
I think you'll always get that. I mean, I can see there's a couple of our developers in here, but in our organisation and our engineering team, then we absolutely need multi-discipline, multi-language, because we've got to do lots of different things. If you're working in the agile way that we do, then you need to be able to move all over the place. Maybe that's not such a same thing. If you're working in a bank, for example, then you might not have that. So from our experience, then you've got to have a polyglot of programming capabilities.
But with as a polyglot, you can usually pick up languages quite quickly because you understand the paradigms, and it's really the vocabulary you end up needing to, and the syntax that you need to shape into. Luckily, most follow the C syntax and make that a bit easy, apart from Pascal, but luckily no one uses that anymore. But then if you go down the Lisp sets, they all look. I mean, actually, an abstract syntax tree is a really great idea. The challenge becomes the portability between projects, of being able to pick up, and I have lost track of the amount of open source projects I have checked out and need to download yet another build tool just to figure out how this runs. And I've got Gradle and Maven and Ant. Why do I need anything else? Because the web world has got 15 different build tools for their flavor of the month. Is that a good thing? Because that's where we're going, is this explosion of tooling.
But isn't it that, I mean, I don't want to talk too much about tooling because I haven't done that much with the large frameworks and stuff and things, but something I, have seen emerge, seems to have emerged, and correct me if I'm wrong, but certainly from my Angular 2 experience, for example, is dependency injection has become a really big topic, and I teach that to my students now, and that Scala promoted that hugely, and it's just that we've improved, and we just learn, we're continuing to learn. I mean, if you rewrote Java today, it wouldn't look like Java. I mean, it would have many of the things, but it would change. For example, the package mechanism probably would be more complicated, and you wouldn't require that classes and file names were the same. I can understand why they did that, but that worked well for a simple language, but hasn't scaled so well with Java. And so I think that we're just improving, getting better.
So if we take...
I just want to say one more thing, I'm going back to you, but I honestly think that if you're a good programmer, you should be able to program at least 8 or 9 languages without anything. First time I ever programmed JavaScript was last year. I have to say I quickly moved to TypeScript because JavaScript's awful, but TypeScript. And, in a couple of days, I was writing reasonably large programs, right? It's not very complicated. And I know there's lots of nuances, particularly around I wasn't quite sure how the callback method worked with respect to the virtual machine. But, it's not that hard to find references. And if you're a good programmer, you should be able to pick that up. And if you're not, then, I don't know, personally, you should be doing something else.
That's good advice.
But to take that,
harsh, but it's true.
To take that point, so for example, at Oracle, you have a large number of programmers, and not all of them are rock stars, correct? I mean,
No, all of them are. Come on, guys.
But statistically, mathematically, the more people you have, the more average you become. It just happens that way. It's a mathematical truth.
I just got to point out that there was a guy I used to work with, and we came up with a thing that he said, which we call Goff's law, and this kind of applies to what you're saying, because he said, when explaining how things go wrong, he said, just remember, half of the population is below median intelligence. And it's the same thing with developers. Half of your developers are going to be below the median level.
And they're not going to be polyglots. They're going to be jobbers.
But come on, I really think that the reason people program in Java is not because of the syntax or anything. It's because the ecosystem is amazing, right?
Right.
And I can't deny that the ecosystem. I program in Java, and it is amazing, the ecosystem.
So is that with Python? You can import after
and absolutely, you just import the world, and then you'll be done, right, with Python. But
I think one of the reasons why so many people program in Java is because so many people learn Java at university, and that's been a great success in terms of feeding into the market to make the number of developers available large, so that people use that for their projects, and it's kind of a self-fulfilling prophecy.
Yeah, I was going to say it probably comes back around because people learn Java, so then they go into the company, so the company's programming in Java, so the university goes, oh, we should teach Java because then
There's jobs.
yeah. But I think in a lot of ways, I think with the languages thing, to a certain extent, you maybe don't want to go too far and kind of there's things around, you have to support whatever languages you're going to do and have build tools and things, so you might want to standardize around that. But I think being able to move between languages is a really good skill to try and encourage developers to build, not just because of then you get to do different languages and it means you can move around, but also more and more technology changes so rapidly that actually you have to learn a new technology anyway every day. So actually by learning a new language, you're kind of still gaining skills of how to continually learn and how to gain new skills, and then you can apply that to then learning a new technique about like how do I do reactive programming, or how do I use Docker containers or things like that.
Absolutely. And actually, there's been this big movement towards decomposing monoliths into microservices and sticking them into containers or sticking them out into the cloud. That only seems to be accelerating. And much like the DevOps movement, is starting to gain traction. And so the future looks like it's more of this stuff. And aren't we just swapping one set of problems that we're familiar with a set of problems we're not?
Yes. I mean, I'm old enough to have seen some of the history of computing. And so I look at this and I think to myself, right, we had RPC, then we had DCE, then we had Corba, and then we had, all of these things like OMG and all sorts of distributed computing environments. And this is just another distributed computing environment. Okay, this time now we've moved on and we have the, what's the word I'm thinking of? Circuit breaker. That's it. That's kind of like the novelty that we have in microservices, the circuit breaker. But a lot of the problems that you're going to have in microservices are going to be the same as the problems that we've always tried to face in distributed computing. It's like, how do you deal with reliability? How do you decide whether a service has gone away when you try to access it and it takes a long time to respond? So do you decide, well, it's just taking a long time to respond, so I will wait a little bit longer, or has it just completely disappeared, in which case I need to spawn a new service somewhere else and then use that? And locating services and then orchestrating services, it's all of those problems are things that you're kind of ignoring by saying, well, microservices are cool because they make things smaller and you can decompose things into easy to manage chunks, and then have different teams work on different pieces, and then everything is great. But yeah, you push the balloon one side and it bulges out the other side.
I think it's about I think that's a really good point, and I think the thing that maybe is different as we move forwards is about what you get from taking on that complexity. And I think the thing that we potentially haven't seen before, and I'm relatively new compared to some other people here to the technology game, but is that we're seeing more and more people want to be able to iterate faster and deliver faster, and it's no longer okay to kind of bring something new out every year. You need to bring it out every week or every hour even. And I think people are maybe looking at these distributed systems and saying, well, yes, we have been here before, but 5 years ago, the complexity the distributed system added wasn't worth the reward that it got for me to move faster. But now the reward gives me more, so it's worth the complexity.
Yeah, I think you're absolutely right. And I've been rather cynical about this in my view, but there are definite motivators for this which are driving it hard. And one of those is the cloud, because we are moving into the cloud and pushing things into somebody else's data center rather than our own. And so it is things like that that are really driving things.
Yeah, and I think, and I go back probably even further. I think you're right, it's still the same old things that you're trying to solve, but what has changed is that the technology and the infrastructure underneath supporting has taken on a lot of this shit that you had to worry about before. Yeah. So it comes back to your point that it allows you to focus on actually iterating and getting functionality and value out rather than it being a science problem to build a complex distributed system.
Yes, because things like continuous integration, continuous deployment, DevOps, the whole idea of that has really kind of pushed things in terms of the tooling and so on to make that a lot easier.
So, sorry, I just want to follow up on one thing. I mean, you talked a lot about that. I don't work in industry anymore, but I saw the kind of agile that came in as I was working in industry, and I can see there's many benefits of it. But I wonder your comment about that we have to deliver products so much immediately. I mean, that just seems to almost map onto agile, right? This concept of agile that you can deliver things and test-driven development, as you say. So, I mean, aren't we just making up this stuff as we go along just because it fits agile? I mean, I don't know. I don't know enough, but I'm interested about it.
No. And so when you look at Oracle or IBM, I used to work for IBM in the past as well. You would build big software releases once a year. There'd be a whole stack, and you'd manage it, and it would be up. We'd have loads of developers that were working to that product cycle, and you'd say, "There's the next .1, .2, whatever release," and you as end users would go through and spend God knows how long trying to get it all together, and you'd get it done, and you think, that was shit, I don't want to do that again. Yep. What we do now, so we still have those people within the organisation delivering that same kind of functional stack, except when you deliver it, you've got millions of people around the world that are consuming it. And it's not all right for us to say, well, actually, we're going to leave that because there's always someone that needs that functionality and using it. So to be able to react and deliver new functionality, certainly when we're delivering it to the cloud that's being consumed by millions of people in multiple data centers around the world, that ability to deliver code from a workstation, from an IDE, whatever it is, through continuous installation, automated test and delivery, through pre-flight, through pre-production, and deliver it out in production data centers is absolutely key to when you're delivering in the cloud.
And so that's a good answer. I like that. I just wanted to understand. But so you are saying that the requirements itself are driven from external resources, and so you're just saying that the agile just allows you to react to those requirements rather than that. You're not using the agile to itself to invent requirements. Because I worked at MD for a long time, and I would say that was the case quite often for GPU features.
Yeah, it might. I'm no doubt that it was, but when if we're trying to deliver new functionality that is either part of the infrastructure or whether it's part of a SaaS delivery, then we can't go through a 6 months testing cycle.
Right, absolutely. No,
You've got to have the tools to allow you to do that continuous delivery, the automated testing, and picking up and when it's not working and being able to repurpose that back into the stream. Vital when we're delivering that kind of infrastructure.
So what you're saying is that we should be able to deliver bugs faster.
Oh yeah, we're getting really good at that. Yeah, no, but it is. I mean, if you're just got a fairly stable system on-prem and you're in a retailer or then no, it's the pressure on the speed of delivery is probably less. So maybe people would use it because it's a cool thing to do.
You're arguing exactly the opposite to what you're saying, that we've kind of come up with these processes, agile and test-driven development, to react to the need in the market.
We certainly use them to be able to react to that. Yeah. No, right. So it's certainly in delivering services on the cloud is absolutely vital.
So as we've been pushed to the cloud, inevitably, Dockerization came slightly behind the cloud. I think it had gone the other way around. We might have seen more use of virtualization continuing internally. But we've also seen a push towards APIs and to consuming APIs rather than consuming libraries. And our dependencies are a network of services now. is that changing the way in which our business has risk, and that we're now locked into vendors? Instead of downloading OpenCV, I'm now consuming a Bluemix image processing API. What happens if you decide to charge 5 times as much, or even sunset it because it's not popular enough? How is this going to change how the risks that we have as developers and the things that we do as developers?
I think that it kind of moves. If you're from a end user point of view, if you're looking at a cloud strategy and saying, well, we don't want to be, what happens if IBM does this, if Oracle does that, if AWS does that, then certainly what we see in our customer base is that people don't have a single cloud provider strategy. If they do, then they end up like half of North America with Amazon. So we certainly see people having a multi-vendor, multi-cloud supplier, and using tools like Terraform, Spinnaker, Packer to be able to automate their deployment, their infrastructure deployment, so it's not dependent upon whether IBM has a 10 times charge in Bluemix. If they do, then well, they obviously come to Oracle. But being serious, that is the way that people are doing it. Certainly, the HMRC strategy is to put everything on Terraform and use IBM, Azure, Amazon, Oracle, VMware, and just put it all through it. They'll just decide where they want to do it based upon the requirements.
Does that, because that sounds like a beautiful future where I don't have to worry about lots and lots of things, but thinking about the impact of that, is that going to then drive down the investment from companies like Oracle and Red Hat in open source technologies, and instead drive that into their own services and the APIs that they're building? Is there going to be less investment from big players in open source technology, and it becomes a hobbyist thing again?
I'll have one word and shut up. Well, more than one word, but I'll make one point. That's within our organisation, there is huge work with open source, absolutely. In the infrastructure side, so we are not having we're not providing our own orchestration tools on our new infrastructure. We're providing Spinnaker support, Terraform support, whatever, to allow people to bring what they want to bring and use our services. So it is not a de-investment at all.
I think going back slightly. Going back slightly to the question you were saying about consuming APIs, and then, okay, if you use an IBM service and that service goes away, what happens? I think the important thing to mitigate that risk is working on the idea of finding, if you like, a public interface, one that's a defined interface. And that's where some of the issues can become a little bit murky when it comes to whether it's, I hate to say this, but whether it's possible to copyright an API. Because that obviously is an issue, because in theory, if you can have an API that's defined for a service, then so long as the API is well defined, somebody else can implement that service. If IBM or Oracle decide that they don't want to provide that service anymore, somebody else can step in as long as they have that API and they can use it. So if, as a developer, you use a well-defined API, which is a public API that somebody else can then re-implement, you're mitigating the risk of that service disappearing.
So does the panel see a cohesion coming to standards across different cloud providers so that spinning things up becomes a more consistent thing? Just like you'd have standards for JPA, having standards for VMs. I believe you can't talk for your organisation, so none of this is briefed. But if we're looking forward, is that the direction that we're heading in, do we think?
I'm not sure. I think it will be interesting to see what happens. I think the one thing to note, though, is that through things like, I guess, open source collaboration, and also just looking at things that are going on, for example, like Docker, you can deploy a Docker container anywhere already. So you could almost look at that as kind of a de facto standard for being able to put something anywhere. I think whether or not it becomes we get an official like standard, or I think there will always be sort of collaborations and things that occur to mean that people can deploy things in different places, not just because then it prevents vendor lock-in and things, but also because it then promotes people to kind of bring in new ideas, and collaboration really does like breed more new ideas, I think. So I think if vendors don't kind of collaborate, then we are going to have less good solutions coming out.
We've seen that with the open container standard with Docker and JetRocket. So there is hope, but I think it takes a bold commercial decision for an older, larger organization than a cool startup Docker to actually embrace competition as something that's good, and portability is good. But I guess we can only
Isn't
wait
it the
and
case
see.
that quite, well, maybe not some of the older companies, we might say these two, but for companies like Facebook and stuff, they clearly make choices, and I'm sure Oracle do as well, and IBM, I know they do, but the point that, they make choices about what IP they really want to protect. Google do that too, and a lot of stuff they do, they open source because they see that it's beneficial to the community and their users as a whole. Whether that be something like React from the JavaScript perspective, or APIs that they're doing around JavaScript. Facebook use those internally. They don't ever release their PHP technology, the C++ and stuff. So it's just a varied, and I'm sure Oracle and IBM do the same thing. There's lots of stuff you don't release to the world, and there's other stuff that you invest hugely into the world. I mean, I just don't see it needs to be black or white.
No, it's not. And when you look at how the likes of products evolve, WebSphere, for example, when it was a long time ago, but it doesn't seem that long to me, then there was real fights between, which was the best app server. Was it WebSphere? Was it whatever? Yeah, that is just commoditized, and the value is moved higher up the stack. So what becomes commoditized becomes, from a vendor point of view, becomes naturally something that you will put out and make, and you will have the higher value, specific value add functionality that you can put on that is the IP of value from that point of view.
Yeah, it's sedimentation, isn't it? Of
Yes.
the technology.
So you mentioned Docker, and that's a nice abstraction there. But there's quite a movement to, such as with functions on Azure or Lambda, and to make that even smaller, serverless, if there's such a thing. It's
I
always
think that's
someone
a
else's
terrible
server.
name. I really do. Serverless computing is just like...
But is that the micro nano that we're heading into?
Well, I don't know. As somebody who's kind of been around the block a bit with this, I don't think so. And the only reason I say that is because, in essence, what you're saying there is everything has to be functional, and state has to go somewhere. So I don't think you can turn everything into a purely functional approach. Well, you could correct me there, but I don't think you turn everything into a purely functional approach with no state. So that state has to go somewhere. And if you start using everything with lambdas on AWS, then where's your state going? I mean, maybe that's my lack of understanding of how this works exactly, but that's the way I look at it.
Yeah, and I think AWS is addressing exactly that point with some of their more recent offers, and DynamoDB is part of that to make it really quick to access, but it changes how you think about the composition of your programs. And I think that is what's alien to this generation of developers who are used to starting up and having a variable and having persist. But these lambdas firing and these functions, in order to deal with the world of IoT, which is going to have millions and millions of these events and event-based computing, where each one of us will have millions of events going off every day, monitoring every part of us eventually. Is there any other way to deal with that sort of scale, if not through this approach?
I just want to point out one thing. I don't think that they're saying you can't have state, right? It's just that you have ownership. So, that's the key thing about it, is that someone, and whatever it is, or something owns it at a specific time, and otherwise you have to share out, like, so some languages like Rust have this notion of borrowing, for example, so you can borrow, and you can do that, scale that up to the cloud. And I think that's the key thing. It's about ownership, and thus you don't then have to have things like mutexes or distributed, queues to block it. I think that's it's not that you don't have it.
We are at 20 past, I'm afraid, which unfortunately someone has to run for a train, so we're going to tag Katherine back in. but we can carry on the conversation. I apologise. This is definitely one of the more erratic versions of this this talk I had.
It's micro panels, see?
It-
Which is changing state. And
It's speaker speed
Boring.
dating. That's it. Who's got a bell that we can ring? Okay, so IoT and the Internet of many things becoming many more things. I can only see that getting greater as everything from my watch through to my shoes now, through to my car. I can tell my car to come around and pick me up soon. Is everything going to be connected? Are we going to end up being connected?
I'd be interested to know what Ben has to say about this, because I was trying to grab him earlier to talk about LoRaN, if that's how you say it. I can spell it, but...
Laura is how I say it, but that's only because someone told me that's how you say it. Yeah.
Which is looking at the limitations of so the problem with IoT is, how do you actually connect the devices? So Bluetooth and Wi-Fi have limitations, and you're looking at something radio-based that fills that gap.
Well, Bluetooth and Wi-Fi have different limitations. Bluetooth has, we're talking about Bluetooth 5 or BLE, has range limitations, although it's very good for power, and it has actually pretty high bandwidth, whereas Wi-Fi has range limitations and has power limitations. You know, it uses a lot of power, and so you're limited. And so the stuff that we're looking at is long range, low power, wide area network, so potentially kilometers for a single router or gateway, as we call them. And I mean, they're all radio technologies, they're just running it, but to get those kind of distances, then you're running it in sub-gigahertz territory, and so the bandwidth is tiny, well, relatively, compared to something where we're talking about 5G networks. But coming back, so I think that there are different trade-offs. So the real thing about that, and that comes from this point, is that these low power wide area networks, which are very small, narrow bandwidth, someone calls them, are really good for certain types of data, you know, applications, and they're really good for censoring. So, for example, great for sending GPS locations or humidity, those sorts of things. And but you're not going to be sending 4K video over it. Well, I'm told 5G, you'll be able to go to the train station, download five video streams at once. I mean, who knows what the point of that is? But anyway, and so what I really think is that lots of devices will be connected in one way or another, although they don't necessarily have to be connected to the internet. They just need to be connected to a controller, and I think that is an important difference. You know, we talk about security in your home. You don't potentially always have to have your home connected to the internet, certainly not all of it, and I think it's a misleading thing.
I think that's looking at it from the thing out is about connectivity, but looking at it from the internet to the thing, it's about security. It's about where do I store the data? What do I do with the data? What do I get? The value do I get out of that data? So it's not. There's a lot of different aspects to that connected, and I think you're right. There's going to be more locally connected,
Right, yeah.
Which is going to be one of the way to address some of the bandwidth, maybe some of the security, but still, what you're going to do with the data? If I'm going to connect to you, you're watching that chair together, then what value am I going to get out of it? It's got to be some data I've got to do something with, and that's what I think the problem is.
Sorry, I totally agree with you, actually, because one thing about the Internet of Things, this huge buzzword, is does anyone actually want all the data? Who here wants all of the data that they could possibly have to be connected? Because, I mean, yes, if you have a farm, for example, which Karina was talking about earlier, Karina Popova, in her talk about AI and IoT, acronyms. And then it's incredibly useful because you want to know which field to send your drone to, which soil needs fertilising. But actually, I don't really care about having a smart home, personally. And I can see that a few people would, but I actually don't think it's going to be a huge, big data revolution, because you've got big data and then you've got big data fatigue.
Well, I don't know, though, actually, and this is why I do think, you know, the cloud and everything plays a part in this, is that, you know, I was talking to someone else today about, you know, this idea that we've got these little things which are monitoring damp in people's houses, just, you know, particulate matter for mold and thing. And we're pointing out that you really need a marker. You need outside. Right? If you're in a street, you don't just want to be in the houses. You want to know what the conditions are like outside. And it's over those 6 month or a year period that you start to see impressions, right? And so I do think actually the more data that we can collect, the more, if we mine it correctly, then the more the interesting outcomes will be for and potentially for the good of the society. You know, health things and for smart houses. We could, if we gathered all the information from people's houses and we knew about the actual structure of those houses. That's the biggest problem, is that we don't know about the physical structures of the houses. To gather that, we could correlate that information and then actually predict what buildings should look like in the future.
Sorry.
I was going to say, I think the other thing that's kind of interesting is you said around like I don't want all the data, is actually I would say about 5-10 years ago I would have said, oh, I don't need Wi-Fi wherever I go, whereas now I'm kind of like I quite like having Wi-Fi wherever I go, and it's the kind of thing that I can imagine sort of sneaking in. Like first you have a smart heater, so you can heat your house when you're out of the house, and then maybe it goes to like your kettle, so you can put the kettle on before you get home. And I think it's the kind of thing that might just sort of sneak in, which is almost where you need to be extra careful with security, because it can almost sneak in before you start thinking about security.
My view about the whole smart home thing is it's been a solution looking for a problem so far, and there hasn't been. I don't think that one thing has happened that is made. That's it. That's what people want. That's what's going to be really useful. That's why it's sort of growing up, kind of piecemeal, and until it gets to a certain sort of tipping point and someone that eureka moment, then I think it's going to happen.
Yeah, although I wonder if there isn't the one. I mean, things like you look at the smartphone now. We look back to Apple's moment, those sort of things, and we can say, okay, it was just waiting for someone to do it right, or whatever, however you want to put it. But I wonder, because there are so many different applications, from all the way from having a smartwatch or to having something very high bandwidth to very low bandwidth. These are very different applications, right? That could. So I'm sure we need. The problem is that the companies need the killer app, because then they can make a fortune and justify it to reduce the costs. But as a society, we might not.
So I think there's two aspects. The first one is making our lives easier. So when I walk out of the room and the lights go off, and that was easy. I didn't have to turn the light off. Moreover, it's saving electricity, which on the small level doesn't matter, but on a nation scale, we may start actually reducing energy bills by and we don't have to remember where we last left our Netflix onto. It already remembers. So if I sit down and turn Netflix on, maybe the lights go off, and making it our lives simpler. But these are all really small things, as is leaving the kettle on when you come home. It's 2 steps, really. And we can get over that. But when everyone leaves the house, did I lock the front door? Did I leave the garage open? Has someone broken into my house? The security aspect, I think, actually becomes quite interesting. But with the Internet of Things comes a massive amount of data, and I've seen some really good uses of it. For example, anyone ever tweeted with #UKSnow? They've stuck these into gritters, and so they've got gritters tweeting their location and tracking where they are, and Surrey Council, as well as Greater Manchester Council, put Android phone in every one of their gritters and said the data's open, where these gritters are open. The Met Office has got open data, so they can now work out where it was likely to drop below, where it rained recently, or there would be moisture on the ground, and that a gritter hadn't been. So they could tell you where the ice is on the road. The other thing that came from that I thought was starting to show really useful data was from cars, mobile phones. So every mobile phone triangulates. Your phone company knows exactly where your mobile phone is if it's turned on, and it's constantly trying to connect. It does that while you're sat in the car. Usually, it's got 4 devices in every car if you've got 4 people, and lots of cars on motorways. So they can tell when a phone stops. And so on a motorway, they can tell the moment an accident happens that you went from 70 miles an hour down to 0. And they can see the truck. They can then instantly use that data if it's pushed out to the transport agencies to be able to set the matrix signs and say, hey, slow down. Actually, if it's gone down to 0, we should probably send at least 1 car. If 12 cars have gone down to 0, we probably send a fire engine while we're at it. That sort of stuff genuinely has a benefit, I think. The challenge that always drives this is the intelligence that comes from this. Same as the security and privacy of your data. I mean, all of this, great intentions and great things you can do with this data. But what if I can now track my ex-partner? What happens now if I could wrongly track someone who I think is what happened to privacy in all of this? And we only have 2 minutes to cover that really small topic. So I'll leave closing remarks and
I'll
we'll
just say
wrap it
close
up.
your Postbank account.
What Facebook account?
Well, exactly. I don't know what I would, you know.
But do you see a future where we're going to have to open ourselves up yet more and more to the world that comes, because that's what we're going to have to do?
I think it's just happening. What I would consider the sorts of information, digital information, that I would care people to have is a completely different attitude and approach to my daughter. It's a completely different. So it's a generational change thing, and it's changing. And when my daughter has, if she does eventually have children, it will be different again. I mean, and that's just the way it is.
So I completely agree. I think the biggest problem is not so much our data or what we can see. I mean, I don't really have a big issue with that. I think probably it's around biometrics, around all that sort of stuff, you know, and health, because that could have an implication on, particularly as we're likely to have health insurance at some point in this country. You know,
You can change your picture. You can change your password. You can't quite change your retina.
Yeah, although you can fake your retina pretty easy, but that's not super difficult. But I mean, the point is that, but not only that, right? But once we can scan and we can predict whether you're going to have cancer and those sorts of things, you know, that kind of data is going to affect the potential, not just the quality of life, but the decisions that get made for you.
And then
right?
you're on to the Minority Report.
Right.
Yeah, I think the
Well,
data
exactly.
question is an interesting one. So I do have a Facebook account, but I'm quite careful about who I add on my Facebook account. Twitter, I'm quite happy for people to follow me on Twitter, whereas Facebook I keep a bit more private. I think one of the interesting things is not only about changing attitudes, but also whether or not those changing attitudes are separate to kind of education and knowledge. And I think that's an interesting one, because like maybe you guys have more experience in security or have some other knowledge that means that I'm like, okay, well, I'm happy to have a Facebook and you're not. But I think also there is like a kind of, I feel like there's two dimensions to it. Do you know what I mean? There's kind of, on the one hand, I've kind of grown up with it a little bit more and kind of like, oh, I'm kind of okay with this, but I still have the knowledge of what's going on. And I think we need to be careful to keep educating people. But I also think over time, people will gradually just become a little bit more happy. I don't know to what extent, because I mean, personally, there are definitely points where I would still say, no, I'm not giving out that information or things like that. Mm-hmm. But it will be interesting to see how far people will go.
Yeah. I have to leave the closing remarks to Katherine.
My apologies. I think it's very interesting. So just as an example, I went to Glastonbury Music Festival a few million years ago and met someone there, and a few weeks later he said, oh, I really like that picture of you and your brother from 2008. And you're like, what the fuck? Stalker. So by being on social networks, you leave yourself open quite a lot. There's a really good example of, I think you sent me this talk, or you sent it to Mark and I watched it, of a guy who tracked down a member of One Direction by the geotags on his tweets and looking at the frequency of his tweet locations, and then looking at the electoral register and then finding his address and his home telephone number. Which
we called Live on Stage.
Yeah, which was really cool.
We made a 13-year-old cry because she got to speak to Zayn. And you cry because of that, of course. But
the thing is, technology and what you can do with it and what you can find out about someone is so far ahead of our social acceptance of that. And I think that's something that we can all help, I don't know how, by educating people and by being part of the future standards of privacy and legislation that comes with it. And I think it's really important that we take part in that.
And with that, we're 5 minutes over time, yay, which is much better than the other times we've tried this. I hope this was relatively interesting. I always find it interesting listening up here, but I'm kind of part of the conversation. Yeah, the future is interesting, and we live in interesting times, and I hope that we continue to. So thank you all for partaking. Thank you for sticking around listening. The closing remarks, I think, for the day are going to be in here about now, and thank you for joining us.